Welcome, curious minds, to another deep dive. Ever stop and think how, I don't know, a smart grid or maybe a big automated factory, how they manage to juggle thousands of operations perfectly
Yeah,
in the right sequence without, you know, making huge mistakes?
it's a good question.
Yeah, so today we're kind of peeling back a layer on one of the, let's call them unsung heroes that make sure all that coordination actually happens.
Right.
We're going to look at a specific building block, one that helps technology just work reliably. Think factory floors, big energy networks, that sort of thing.
And that's exactly why getting these fundamentals, these often sort of hidden bits, is so important. We're not just talking ideas here. This is about really careful engineering of individual pieces.
Yep.
The precision, how they're defined, how they operate.
Yeah.
Honestly, that's the foundation for making automated systems robust, predictable, and importantly, safe.
Right.
Without that level of detail, the whole structure of modern automation, just wouldn't hold up.
That's a really strong point. And the core of our deep dive today, the specific piece we're digging into, is called the function block e-permit.
Hmm.
Now, for anyone maybe not familiar, function block, is that just a general description, or is that title, especially for e-permit, pointing to something really specific and precise?
Oh, it's definitely not generic, no.
Yeah.
ePermit is a very, very specific type of function block. And what's fascinating, I think, is how it's defined. It's not loose at all.
Okay.
It's laid out with extreme precision in Annex A of IEC 614991. Now, that's standard, IEC 614991. That's specifically for distributed industrial automation systems.
Oh, okay. Industrial.
Exactly. So right away, that tells you it fits into this bigger, very regulated picture. It's all about ensuring things work together, interoperability, consistent behavior, no matter whose hardware or software you're using in these really complex industrial settings.
Okay, so if it's defined that precisely, what's its actual job? Its core mission. The description is permissive event propagation. Can you maybe give us a feel for what that actually looks like? What is permissive event propagation doing day to day beyond just, controlling flow?
Yeah, absolutely. Think of ePermit like a really smart gatekeeper, not just for any flow, but for a critical sequence where safety or, system integrity really matters.
Okay, like a safety check.
Exactly. Imagine a robot arm in a factory, right? You absolutely do not want that arm extending unless specific safety conditions are met.
Like what?
Well, maybe the safety guard has to be closed and sensors need to confirm there's no person in the work zone, things like that.
Gotcha.
ePermit is the block that makes sure the extend arm event, that command, only propagates, only goes through if all those specific permissive conditions are true.
So it checks multiple things.
Yes, it's about making sure that critical next step only happens when it's genuinely safe and appropriate. It stops potentially costly errors or even, really bad accidents.
That example, the robot arm, that makes it much clearer. Okay, so how do we know exactly how this gatekeeper, this e-permit block, behaves? It's not just a text description, I assume.
You're right, it's much more rigorous than that. Its operation isn't left to chance or just some informal description. Its behavior is strictly modeled by the execution control chart.
The ECC.
ECC execution control chart.
Correct. And this isn't just a simple diagram. It's a formal model based on states and transitions. This is, well, it's critical for ensuring its behavior is deterministic, predictable, and verifiable.
Verifiable meaning you can prove it works correctly.
Precisely. The ECC defines the exact states the block can be in and the transitions between those states based on incoming events and conditions. It gives you this clear visual blueprint that's so precise it can be formally checked.
Okay.
So basically, any engineer anywhere knows exactly what to expect from an e-permit block, no matter who actually implemented the software or built the hardware. Right. So when we zoom in this much, talking about one specific thing like e-permit, its exact definition in a standard like IEC 61499901, its behavior pinned down by an ECC. What does this really mean for you listening in? Why should you care about this level of detail?
Well, I think it means that understanding these kinds of precise, standardized components, it really helps you appreciate the incredibly complex, but also incredibly carefully designed architecture that's underneath so much of the technology we use. The reliability we just sort of expect now in everything from industrial plants to maybe even your smart home devices.
Yeah.
A lot of that comes directly from this level of meticulous detail and standardization.
Okay, so as we start to wrap up this deep dive then, hopefully it's kind of reinforced this idea that digging into these granular, really precisely defined elements like function block epermit, it actually gives you powerful insights. Insights into how these incredibly complex systems get engineered and maybe most importantly, how they're made reliable. Just knowing about these exact definitions, it can give you a whole new appreciation for the underlying structure, the ingenuity behind it all.
Exactly. The importance of standardized function blocks
Yeah.
and their, rigorously defined operations like this permissive event propagation,
Right.
formally modeled with an ECC, all inside a standard like IEC 614991, you really can't overstate it.
Right.
They're truly the fundamental building blocks. You build bigger, more complex functions on top of them, and they guarantee consistency, interoperability, robust performance across all sorts of different automated systems. These seemingly tiny technical details, they really are the bedrock.
So maybe here's a final thought to leave you with. How does knowing about these foundational, really precisely defined building blocks, even something as specific as permissive event propagation and the formal charts that map its every move,
hmm
how does that change your perspective on this invisible architecture that powers so much of our connected world? What other specific standardized components, things like ePermite, might be ticking away behind the scenes, making sure the systems we depend on work perfectly that maybe you've never even thought about before?